Hi students, the first subject we are starting in RRB and SSC JE is strength of material. The main reason is this has a weightage and this is a independent subject. Independent means which it don't need knowledge of any other subject to start strength of material. If you want to start RCC steel structure, you have to know strength of material. If you want to start geotechnical engineering, you have to know SM and FM. Even transportation engineering also, analysis needs some part of strength of materials. So, strength of material alone can be learned, fluid mechanics can be alone learned individually. So, subject with good weightage and independent subject, which is primary in most anywhere, mostly we will be starting with strength of materials generally, that is the primary reason to start with this. And whatever the syllabus that we are going to cover here, I shared SSC and RRB JE comparison syllabus. So, whatever the syllabus we have in SSC and RRB completely will be covered. For your particular state government examination, if you have a different syllabus, means one or two subjects, you can study that individually, but whatever we are covering, we will keep in mind about the state government level jobs as well while covering the syllabus for this particular subjects, okay, which are common with state government jobs, okay, which are exclusively for SSC and RRB, we will cover in that point of view, which are combined with state government, we will cover your state government as well parallelly, so that you need not study for state government separately, okay, right. So, this is the syllabus we are going to cover, but may not be in this order, I may change the order here and there to create a flow, okay, but somehow we will cover everything, okay. Compared to regular state government jobs, generally this friction and simple machines will not be part of syllabus. Particularly for APPSC, AEE, you have this friction and simple machines as well, but for majority of the state government syllabus, generally we will not see simple machines in the part of their syllabus, anyway we will be covering this as well, okay. And force analysis, which is a part of engineering mechanics. So, these are the topics we will be covering. I think most of you have already seen this PDF, okay. Right. So, before starting strength of material, first I will get you into the subject of strength of materials before entering into one of the topic, okay. So, first before understanding strength of materials, first let us understand deformation, okay, deformation and displacement. This is very important in understanding the strength of material. Complete strength of materials is depending on this only, okay. Okay. So, whenever we are taking a body and applying load on that body, the body will deform, and the particle will displace, the body will deform and the particle will displace if it is a deformable body. If it is a rigid body, even if you are applying load, it will not deform. Such bodies are called rigid bodies. Rigid bodies, deformable bodies. In engineering mechanics, we deal with this. I will tell you the reason also. And in strength of materials, we will be even in structural analysis also we will be dealing this, okay. So, before explaining this, first let us understand the deformation concept. What is deformation? Deformation is relative displacement, of the particle, but not the entire body, okay. For example, see if I am taking this small rubber band and deforming it. So, the shape of the body is changed for sure, yes, the shape of the body is changed, but the body did not displace from its position, right. So, if the body is displaced from its position, this is rigid mechanics, because you are not considering the deformation of the body, the body is displacing without deformation. So, we consider this type of bodies as rigid bodies, means without deformation the body is displacing, okay. So, this we study in engineering mechanics, okay, and deformable body in strength of material. The reason is generally in engineering mechanics we deal with moving bodies, not in every topic. In some of the topic like force analysis, to understand equilibrium conditions, maybe you may be dealing some static bodies, but in general engineering mechanics is about the moving bodies, and strength of material is about the static bodies. Okay. So, this is a part of structural engineering. Anyway, once we get into the subject, I will explain that in details. So, strength of materials deals with the static bodies. Static does not mean it is not deforming or moving. It is moving, but relatively very less movement. That is caused because of the deformation of the body. Deformation of the body, but the entire structure is not displacing without deformations. The deformations of the body is creating slight displacements. Okay. In this deformation also, there are two types of deformation. One is elastic deformation, second one is plastic deformation. Our complete syllabus in strength of materials is only dealing with elastic deformation. Elastic deformation means after removing the load, it has to come to its original position. Maybe most of you as a civil engineer might be aware of this. So, if you are deforming a body in various ways, see, I can even bend and it will come to its original position. It will come to its original. See, if I am holding the body like this and deforming, the shape is like this. If I am holding this on two sides and deforming, the shape is like this. If I am applying the load like this, you can see the shape of the deformation is changing. Okay, keep that aside. First question is, why we need force to deform a body? We know we need a force to move a body. We need a force to move a body, particularly to change the momentum of a body, as per Newton's law if you want to say. To change the state of its motion, we need a force, obviously, we know by Newton's law, because of inertia. So, similar to inertia, to deform a body also we need some force. To deform a body also we need some force. Okay. Why we need that force? Similar to inertia, the body also will have a resistance to deformation. Resistance against deformation. This is called as stress. Without starting the subject, I am telling this basic so that you will understand the name of the topic clearly by knowing these terminologies initially. Okay. So, why we need force to deform a body? Why we need force to deform a body? Because it has a resistance. Okay. In that particularly, we are dealing only with the elastic deformation, which will come back to its original position. Okay. Now, I will ask you some question. See this wire. Okay, see this wire. Now, tell me whether it is displacement of the, here deformation of the body or displacement of the particle. In engineering mechanics, we deal with displacement of body. This is engineering mechanics. Okay, this is SM we can take, right? I hope this is clear now. Okay, so you have a wire like this. Now tell me whether it is deformation or displace. See, the wire did not move from this place to this place, right? You see, it is moving. Now this is deformation or displacement. The answer is it has both. I will show you how. If you try to feel, you will not have any stress in between this, and you will not see any deformation or change in shape of the wire between this, except the places where I am holding, right. That is why this wire will have stress only in the places where I am holding, but not in between, right. So, the particles in between these have not deformed, they have simply displaced without creating the stress, right. But the particles here slightly deformed to give that displacement. You are able to, so here the obviously the shape of the wire will be changed here, right. So, now I hope you understood the difference between deformation and displacement. Okay. So, whatever the deformation we are telling you, that deformation has to be elastic to study in strength of material. Okay. If the displacement is not coming back, it is a plastic deformation, that is a different concept. which is not required for our analysis. Okay. So now strength of materials deals with elastic deformation. Elastic deformations of the static bodies. Okay. So static body doesn't mean it is not moving. The displacements are relatively very less, and the displacements are caused because of the elastic deformation. So the deformations must be within the elastic zone. Okay. Every body will have two stages actually. One is elastic deformation, second one is plastic deformation. Okay. So whenever we are deforming a body, the body cannot deform continuously till infinity. After a particular stage, initially it will have elastic deformation which can come back, and after that it will have a plastic deformation. This is not our subject. We deal only within the plastic range. So the structure has to move within the elastic deformation limit of that particular material and come back. So we have to design a structure so that when we apply a load, the structure deforms within the elastic limit and come back when we remove the load. When we apply the load, the structure has to deform within elastic limit and come back. It should not go to plastic limit. This is how we have to design. Till this we are designing. Okay, there are few stages where we design plastic also, for particularly for steel structure. That is a different concept. We will deal that separately. But within strength of material structural analysis, we deal the deformations of the static bodies which are not moving but moving slightly within elastic deformations. Okay, this is our syllabus. Okay, so in this elastic deformation also we have different types of deformations. Okay, so whenever we think, okay, we are deforming, why we need to have force? Because there is a stress. What kind of stress we are getting in this? This is strength of materials. Okay. So when we are deforming, we are getting a stress. Until a particular deformation, we are getting a resistance till the elastic limit. After that, there is no resistance, that is plastic deformation. After the plastic deformation, the body will break and go into engineering mechanics. The body will be moving continuously. So there are totally 3 stages, that is initially it is static. When you are applying the load, it will deform in elastic stage, and then it will create a plastic failure, and then permanent failure. Permanent failure means breakage. So almost every material will behave in the similar pattern. Okay, there are few exceptions anyway which do not have any elastic reasons, but more or less all the engineering materials will have similar kind of behavior. It will have some elastic limit followed by plastic limit followed by failure. Okay. So we have to make sure to apply the loads within the elastic limit of the body. Okay. Okay. So what are the type of deformation a body can face? Okay, in how many ways we can deform this body? So I have given you a body and asked you to deform, not displace, okay, you can displace in various ways. Okay, you can displace in various ways, but I want only deformation. One thing is we can stretch this to deform. Okay, this is tensile. Still I have not entered into strength of material, I am telling only the basics, because many students will not understand the deformation. When I am teaching directly strength of material, they are unable to understand the deformation. So this time I thought, let us make it clear about the deformation and start strength of materials. Okay. Okay. So when you are deforming a body by extending the body, this is tensile deformation. Okay. Next, I hope you can understand compression directly and bending. Bending, already I have shown you the bending. So when we are bending a body, what is the kind of resistance we are observing in this body? Similarly, when we are twisting a body like this, I hope you can see the twist. This is twisting, this is bending, this is tension. Okay. So like this, whenever, in how many ways we can deform a body? You may think, so like this also we can deform. Yes, that is also in our syllabus. Continuous loading, fatigue, cyclic loading, fatigue. That is a different, which we will not study exclusively, but we will study that also. But majorly in our syllabus, there are 4 types of deformations which we have to understand for sure. Okay, that is, you can apply tensile load, you can apply compression load, you can apply bending, and you can apply. Whether you are applying the load or not is different. What is the deformation you are getting, that is important. Whatever the deformation we get in this twisting type, this is called as shear deformation. Let me write this also separately, shear deformation, because this can be applied individually also separately, like pure shear. Without torsion you can apply shear also directly. Okay, directly you can apply shear, or through twisting also you can apply shear. Twisting also we get shear only, shear types of stress, not separate. Okay, so load you may apply separately, but the deformation whatever you are getting is shear deformation only in twisting also. Okay, so these are the major type of deformation we have. Okay, next, coming back to our syllabus. So whatever the deformations we have seen now, that are the major deformation. Complete deformation we will discuss once we enter into the subject. So in the initial topics, simple stresses and complex stresses, what are the type of resistance we get by deforming a body in various ways, whatever I have shown you. What is the type of resistance we get in one direction is simple stress, in 360 degrees various directions is complex stresses. Various type of resistance, this is engineering mechanics, centered on moment of inertia. Next one is shear force, bend moment and torsion. So as per the syllabus, initially we have to deal with the stresses, and then we have to tell about the forces that are causing this. But this time initially I will tell about the forces, and then I will tell about the stresses to create a better flow in the subjects. Okay. Next one is bending stress, stress resistance or resistance shown by the body when we are bending. What is the type of resistance we are observing this? How the body is resisting when we are deforming in terms of bending, why it is coming back. Similarly twisting, so when we are twisting a body, what kind of resistance it is showing, and how much deformation. See the deformation, if I am holding this body here, this is how it is deforming. If I am holding here, this is how it is deforming. Means depending on where we are supporting the body, the deformations are changing, right. So what is the amount of deformation based on something called boundary conditions, we will calculate in this. And with this the concept of strength of materials will complete, and from this we will have only applications related to and strain energy. This is also separate. Compression members, springs, all these thin cylinders which is not represented here, which is not in your syllabus, but we will cover basics of thin cylinders as well, that is applications. And what is the amount of energy we are losing while applying this load, that we will be studying strain energy. Okay. So this is your syllabus majorly. And as I said, initially I will be starting with forces, that is shear force diagram and bending moment diagram will be the first topic we are starting. Before entering that topic also, once again let me tell you clearly the difference between the forces and moment. Okay. So there are totally 3 types we have: force, moment and stress. So these 3 words generally will be confusing you. Majorly our strength of material deals with this only, but understanding this is also very very important. Okay. So now I told you about tensile force, compression force, shear force. Okay. And regarding moment, I told about bending, twisting moments. Okay. So all this will create what type of stresses we have? Tensile stress, compression stress, shear, which is same in twisting, and in bending also we get similar to tension and compression. In bending we get both tension and compression as well, which is a different case. Okay. So majorly we get only 3 types of stresses, that is tensile, compression, shear. Okay. These 2 are called normal stresses, and this is tangential stress. Okay. So in our syllabus, what are the various type of forces we are acting on the body, what are the various type of deformations it is taking place, because of the deformations what is the amount of stress or type of stress we are getting in the body. Okay, this will be the syllabus, and in the last we will see what is the amount of deformation we will be calculating, amount of deformation or rotation whatever we are getting we will be calculating in slope and deflection. Okay. So, understand the difference. This is engineering mechanics which is moving the body. This is strength of material which deals with the static body. So, in strength of material whenever I say a force, by default it means there is other force to keep that in static condition. In engineering mechanics it need not be like that. Similarly, even for moments also, okay, or even you can have a torsional. One more thing, in engineering mechanics torsion moment and bending moment is the same thing, because the body is not deforming. In bending and twisting the deformation nature is completely different, but as it is a moving body, in engineering mechanics there is no distinct difference between torsion and moment actually, but in strength of material the two are completely different, which is causing the twisting and which is causing the bending. Okay. So, in next class we will be starting the first topic of strength of material, that is shear force diagram and bending moment diagram. Which is nothing but this. Okay. So, initially we will study about the forces, next simple and complex stresses because of the forces we are applying. Okay. If you are a beginner starting strength of materials newly to the competitive field, you try to feel the difference between deformation and displacement in your daily life as well. So, for example, if I am walking here and there, my body parts are deforming or displacing. See my fingers, this is deformation or displacement. Try to identify, is it creating a stress? No. So, this is a displacement, this is a displacement, right. But because of my weight I am standing, my legs are paining, means it is creating a stress, right. This is strength of material. I am static and I am getting stress, means because of standing definitely my body would have deformed, means whenever I am standing and whenever I am sleeping my length would be different for sure. It may be negligible, but as a elastic nature of the body, definitely when I am standing I am applying the load in this direction, when I am sleeping I am applying the load in this direction. So, definitely even though the weight is constant, the method of applying the load is different. As I said, based on the type of load we apply, the deformation of the body is different. So, definitely when I am applying the load in this direction and in this direction, the length of the body must have changed. So, your height when you are standing and sleeping is not the same. So, if you want you can physically measure that. Not only that, see if you are traveling on the road, you are applying the load to the road, so obviously the road will get deformation in a different way, which is not in strength of material, because that is not an elastic deformation, that is a different deformation which we study in pavement analysis, it has a separate subject, right. So, in our daily life also we are surrounded completely with the deformable bodies. Our structure itself is a deforming body where we are standing. Every day we will be deforming, even while making a chapati, when you are making a dough, you feel the plastic deformation of it. Okay, it is not, whenever we are changing the shape, it is not coming back. So, it is a plastic deformation, which means that there is no stress saved in it, right. So, I hope you can feel the situations where the deformation is giving the stress, where the deformation is not giving the stress, where it is displacement but not deformation. Okay. So, while you are making a chapati, you are deforming, changing the shape, but still you are not getting the stress inside that, because that is a plastic deformation. Okay. So, that is how we can understand the deformation. So, in your daily life also you try to observe some examples and feel the deformation and displacement, so that you will get into the subject very easily from the next class. Okay. Thanks for watching.